calculus students don't know because we skipped this last year. This year's AB kids don't know it. BC's probably forgotten it. So you can have a 1-up on them. All right. We are going to talk about Pascal's triangle today and the binomial expansion. Okay? So like I said, there's some nice pattern stuff to this. So it makes it kind of fun, I think. Okay, so we need to, that's not there. Let me find, give me 1 second. I want to find my answer key. It's not in there. Let's go. Thank you. Okay, so let's talk first of all about how to create Pascal's triangle. I think you have the little blanks there, right? Okay, so the thing you got to know about Pascal's triangle, there's some rules to it, okay? And the first rule is my top number is 1, and all my numbers on the outside are always 1. So it always starts with a 1 and ends with a 1. And I don't know if you have more rows than I do. Do we have the same amount of rows? I don't know. I didn't. Yeah? Okay, great. Okay. And then beyond this first 2 rows here, the way that we create the triangles, see how we're kind of set up where these 2 numbers here kind of over the top of this one in the middle. So to create it, you add these 2 numbers together. So what's 1 plus 1? 2. Perfect. All right. And then 1 plus 2 is 3, and 2 plus 1 is 3. So that creates the middle. And then 1 plus 3 is 4, and 3 plus 3 is 6, and 3 plus 1 is 4. 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, and 4 plus 1 is... All right, everybody create the 6th row, 7th row, okay? Create the last 2 rows on your own. All right, let's check them. So what'd you get for this next row? What was the next number? 6, 15, good, 15. Do you see how there's a pattern? Yeah, it goes back and forth, okay? And some of them, if it's an even row, we get a number in the middle. If it's an odd row, we get, it just, the 2 numbers repeat right away. Okay, what's the last row here? Now, there is a connection to this. We don't use it in here as much, but remember last year when you did combinations and permutations? Yeah, so there is a connection to the combinations, permutations, and how you get the coefficients. We aren't going to probably go above the 7th row, so I'm not going to mess with that so much, okay? You can probably figure out what you need to based off of what we have here, okay? All right. So for the test, you're probably going to want to know how to write out the first, at least up through 5, 6. You could probably get to the 7th row. Okay, I'm not going to go beyond 7 on the test. All right. So we've been doing that for a long time, right? We've done it by FOIL. Okay, so let's do that first one by FOIL so you can see this pattern. And then I'm going to do the second one with the pattern. Okay, this is what we call binomial expansion. Okay, so you notice it says expand. So by FOIL, we would say x plus y times x plus y. Okay. So what's x times x? X squared. X squared. What's x times y? And how many of those do I have? 2. And so I put a 2xy, and what's y times y? All right, and then we'd had pluses in there. And what I want you to notice is I want you to notice these coefficients. 1, 2, 1. Look in Pascal's triangle right there. What do you notice about that row? It's the same thing, okay? So we can use the coefficients of Pascal's triangle to expand a binomial, okay? These will become the coefficients. Now we're gonna make it more complicated than just writing those in there, okay? We're gonna throw the advanced math twist on it here in a few minutes. There is also a pattern with the exponents, okay? If what I typically do is I'll write out the two variables x, y, okay? And with the x, the first one you start by counting down 2, 1, 0. And then you can count up, either count up or come from the back, 2, 1, 0. Okay? So make more sense when we do one more. Okay? So, first thing I do is I know I've got to go to which row of Pascal's triangle do you think? Third row. It tells you in the exponent what row to go to. So I'm going to go to third row, and I'm going to start by just writing those coefficients out and leaving myself some good space. Okay? So what's that row? Read me that row. 1, 3, 3, 1. Perfect. Okay. Now I'm going to write my variables in there. Okay. And I'm going to do this every time. I know my variables are x, y, so I'm going to write x, y in there every time. Or at least on this one. Whatever's in the front, whatever's in the back, I write them in there. Then I'm going to count down first. I'm always going to start with whatever this exponent is. So I'm going to go 3, 2, 1, 0. Then I'm going to come back here and I'm going to do that again, but I'm going to start with my 3 at the right end on the y. So 3, 2, 1, 0. Look at the two exponents. What do they all add up to? They all add up to 3. So they should, all your exponents, to know that you've done it right, all add up to whatever your original was. Your original exponent was, okay? Now, we don't like seeing 0 powers, right? We're going to get rid of that. We're probably going to get rid of our coefficient of 1, all right? So to write the pretty version of this, I would say x cubed plus 3x squared y plus 3xy squared plus y cubed. So a few years ago, it's been a while, but a few years ago, I had a student in calc who he would use this and have it multiplied out, and everybody else would still be multiplying it out 3 times. Remember, we did the 3 times out earlier this year, right? So we could have used this and gotten there in 2 lines versus it took us a foil and a box, right, before? Yeah. So that's a lot nicer. Okay, so if you can remember to do this, this is a good shortcut. So the thing is, though, we're not just going to stay cubed. Look at this one. This goes to the 5th power. Okay, we're definitely not doing that by foiling in boxes. Okay, let's use this binomial expansion on it. So we got to go to 5th row of Pascal's triangle. Read me the row. What's the row?
1, 5,
10. And notice you leave space after. You have to get in that habit, right, of leaving some space. Okay, then I'm going to go to my variables. My variables are still x, y, so I'm going to go x, y, x, y, x, y, x, y, x, y, x, y. Now I'm going to put some exponents on them. So what's my first exponent on my x? 5, and then you count down. 4, 3, 2, 1, 0. And then what exponent's going to go on my y that's most to the right? 5. So 5, 4, 3, 2, 1, 0. And then you do a brief check to make sure all your exponents add up to 5. We good? All right, and then if there's no sign in there, we throw plus signs in, not that you need it in that row. I'm going to go a cleanup line. So x to the 5th plus 5x to the 4th y plus 10x cubed y squared plus 10x squared y cubed plus 5xy to the 4th plus y to the 5th. All right. Let's try, I'm looking ahead here a little bit. Okay, here's what I want you to do. Okay? I want you to try number 4 on your own. Okay? Instead of XY's, it's AB's. That shouldn't be a big deal. So everybody try to expand number 4 on your own there. Make sure you leave it, write small, leave space, right? Give you about 10 more seconds and we're going to check it. Okay. Do you agree with my coefficients? Okay. What number do I need to start with on this A? 7. 6. Good. So if you can count today, you can pretty much do this, right? Okay. What about what's going to go on this B down here?
7.
Perfect. Okay. All, and technically plus signs in between, I'm just going to write the clean line. So a to the 7th plus 7 a to the 6th b plus 21 a to the 5th b squared plus 35 a to the 4th b cubed plus 35 a cubed b to the 4th plus 21, I'm going to run out of space, plus 7 ab to the 6th, oh, maybe not, b to the 7th. Just barely made it. Okay? We good with that one? Okay, now we're going to make it a little bit more advanced. Okay, because that's just a coefficient of AB, or sorry, variable of AB isn't very interesting. Okay, let's make it more interesting. So notice instead of variables, I now put some numbers in there. Okay, so that's going to end up changing your coefficient here in a little bit. I'm going to start it the same way. What row of Pascal am I going to? 4. Okay, so we're gonna. What's my row? My 4th row. Notice I'm leaving space. Always leave space. This is a good day if you wanted to do your homework landscape way instead of portrait way, okay, in your notebooks, okay, because you got to get these expanded. All right, so the next thing I'm going to do is just what I did before. I'm going to write, but notice I'm using parentheses, I'm going to write both of my terms down. So 2x negative 3, 2x negative 3, 2x negative 3. All right. What's my first exponent on my 2x? 4, 3, 2, 1, 0. Now what's my first exponent on this 3 down here? 4 again. 3, 2, 1, 0. I'm going to give everybody about 20-30 seconds to get caught up. So I want you to really carefully see what I do next. Okay, it's Monday morning, we're teenagers and we're lazy, right? So, the least amount of work possible, the better, right? Okay, so, I already know that's going to go away, it's going to be 1, right? So and the same thing with this one down here is going to be 1, so I'm just going to kind of get rid of it, okay? If you wanted to, you put a little arrow, goes to 1, but it goes to 1. We don't need to mess with it. All right, right underneath here, I'm going to do a little bit of scratch work, and then I'm going to write it pretty. Okay, and I'm going to do this term by term. What's 2 to the 4th? 16. Perfect. Notice I just wrote the little 16 down there. 1 times 16 would be 16, right? And it's going to be x to the 4th. Okay. What's 2 cubed? 8. So in this term right here, I have to multiply 4 times 8 times negative 3. Tell me what that ends up being. You have calculators. Negative 96, and we still have the x cubed, right? All right. In this term here, what's 2 squared? 4, and negative 3 squared. 9. See how I just write it underneath? That's enough for me to be able to see, okay, now I have to multiply 6 times 4 times 9. What's that? 216x squared. Because the x is still, we still got to square the x. All right, 2 to the first is 1, or 2, sorry. What's negative 3 cubed? Negative 27. So I have 4 times 2 times negative 27. What's that? You guys can call it the answer. Negative 216, and I have an x hanging out, right? In this term, the x went away. All I need is negative 3 to the 4th. What's negative 3 to the 4th? 81. Okay, so there is the final pretty answer. Okay, so not so bad. It was one extra little step that we had to deal with. All right, let's try another one of those. So this time, oh, mine says that's not the example you have, is it? Is it? Oh, okay. I'm looking at an old presentation. Okay, let's try that one then. So we've got, notice the x is squared, so that makes it a little bit weird. What's the third row of Pascal? 3, 1, right? So I'm going to write x squared and 3, and x squared and 3, and x squared and 3, and x squared and 3. All right, what exponent's going to go on the first x squared? 3, 2, 1, 0. What exponent's going to go on this 3 at the right? 3, 2, 1, 0. Okay, let's start simplifying. So I know that 3 to the 0 goes to 1. My coefficient's going to be 1. Remember, what do we do with our exponents when we have a power to a power? Multiply. So we get x to the 6. And notice I leave a gap of space in there because I might need some scratch work in there. Okay? All right. Doesn't look like I really... Oh, I need to know what 3 times 3 is. What's 3 times 3? 9. X to the what power this time? 4th. Good. What's 3 squared? 9 times this 3 is 27x to the 2nd, or squared. All right, we know that 0 power goes to 1. What's 3 cubed? 27. Not so bad, right? Oh, there it is. We just switched the order up on it. Okay. Let's look at this next one. This next one's more similar to what we did in example 5. All right, so what is my 5th row of Pascal's triangle? 10, 10, 5, 1. All right. And then we're supposed to write out x and negative 2y. So here's what I want you to do. I want you to see if you can get the calculation correct. So from here, I want you to try to finish it. So I'm going to give you about a minute and a half. Everybody try to finish it. All right, let's check it. So let's see, I should be at 5, 4, 3, 2, 1, right? 0, and then 5, 4, 3, 2, 1, 0. All right, we know that that first term is gonna go away, right? That's gonna go to 1. So we just get x to the 5th. 5 times negative 2? What'd you get? Negative 10, x to the 4th, y? All right, what's negative 2 squared? 4 times 10 is 40x cubed y squared. What's negative 2 cubed? I heard it. Negative 8 times 10 is negative 80x squared y cubed. And you should be noticing, I didn't write signs down on purpose, right? Because this is a place where the signs change possibly in that final answer. All right, what's negative 2 to the 4th? 16 times 5 is 80x y to the 4th. The x to the 0 we know is going to go to 1. What's negative 2 to the 5th? Nope. Negative 32y to the 5th. Remember, it's 2 times itself 5 times. Okay? All right, we okay with that one? All right, we've only got one more. Short day, right? Easy day. All right, here's where we really put another twist on it. Remember eyes? Okay, we can get it into eyes too, okay? So, or use this with the eyes too. So let's look at what happens with this one. So we've got, for 5th row, Pascal's triangle, what is it? 5, 1. Okay. And then we do the same pattern we did before. We do a 2 and a negative I. 2, negative I. 2, negative I. 2, negative I. And 2, negative I. All right, what exponent do I start with on the 2? 5, 4, 3, 2, 1, 0. And then here we start with a 5, 4, 3, 2, 1, 0. All right, we know anything to the 0 power is going to go to 1. So what's 2 to the 5th? 32. Okay, what's 2 to the 4th? 16 times 5 is 80, and then I to the 1st would just still be negative I, right? I shouldn't have written, oops, sorry. What, uh-oh, I just deleted all of it. That was good. That was no-oh. All right. Let's see, I'm gonna have to just redo it, aren't I? 1, 5, 10, 10, 5, 1. Sorry about that, negative I. See if you can get it finished. While I'm doing this, see if you can do the intermediate calculations, okay? While I'm redoing. I see that maybe I did it on purpose. I didn't, but okay. I was trying to change colors. 5, 4, 3, 2, 1, 0. 5, 4, 3, 2, 1, 0. Okay. So we had 2 to the 5th was 32. We said that this turned out to be 16, and then it would have been negative 80, right? Negative 80i, right? Because we've got the negative 1, the 16, and the 5. Everybody good with that? All right, what's 2 cubed? 8. Negative I squared is the same as saying 1, right? So 10 times 8 times 1 is 80. All right, what's 2 squared? 4. Negative I cubed is the same as saying negative I. Okay, so what's 10 times 4 times negative I? Good. Negative I to the 4th is the same as saying 1, positive 1. So 5 times 2 times 1 would be 10. And then let's see, 2 to the 0 is 1. Negative I to the 5th is negative I, so minus I. Now we're combining like terms and it should be a binomial answer, right? So 32, 80, and 10, or 90 plus 32 ends up being 192? 122. Okay. Do I have... Should this have been a negative? No, it shouldn't. Oh, I did screw up. What is... That should have been a negative 1, shouldn't? Negative I squared. No, it isn't. It's a positive 1. I agree with the positive. Because a negative... I squared is negative 1 times the negative, right? Yeah. I'm looking at last year's answer. I was wrong last year, so... Or 2 years ago or 3 years ago, whenever it was I last taught this. All right. And then we've got negative 80i, negative 40i, and negative I is negative what? Negative 121i. So there's your final answer. Okay? All right. That's it. I did split the homework into 2. Okay? Because we're not only running into tomorrow's the last official lesson in this chapter, okay, which means we're running into a test. We're going to put the test next Wednesday. But we also have a 3-day weekend coming up. Because, you know, we weren't just on vacation, so we need a 3-day weekend. So, okay, and in a couple of minutes here, in 2 or 3 minutes, I'm going to come around and stamp, okay? So we'll get that first week of homework in, hopefully.